Hi, welcome to Learning Monkey. I am Vikram. In this class, we'll try to understand algorithm analysis examples 3. So this is our third video on algorithm analysis examples. In our previous videos, we have covered algorithm analysis 1 and 2. There we have explained some of the algorithm analysis. So we have taken some examples on algorithm analysis. If you haven't watched those videos, please watch those videos and come back here, because we are going to explain the concepts in this video based upon the assumption that you have already watched those videos. And every video in our channel is going to be part of entire course or a playlist. Our suggestion is to follow the entire course so that you can have better understanding of the concepts. And the link for the playlist is provided in the description below. Now coming to this class, so this algorithm, so how many times does this line of code will get printed, so that we will try to understand. And very important point that we have covered in our previous video is whenever we are trying to analyze an algorithm, we have to check whether the for loop conditions are based upon the previous for loops or not, so outer for loops or not. That we have to verify. First we have to check if there is such dependency, then we have to evaluate those the efficiencies of those algorithms. So for example, if you take this algorithm here, this loop, we can directly say that the first for loop, the outermost for loop, is going to iterate for n number of times. So this loop is going to iterate for n number of times, because I is equal to 1, I less than or equal to n. So based upon the value of n, this loop is going to iterate those many number of times. Now this for loop, so how it is going to iterate? Its iterations, the iterations of this for loop, the number of iterations that are done by this for loop is dependent on the value of I. Try to get that point. See here, this is very important point to understand. So by these dependencies only you can exactly you can exactly analyze the algorithms. So here the value of j is dependent on the value of I square. So how many times does this loop has to be iterated is dependent upon the value of I square. Okay, so make a note of this point. We will try to analyze this step by step. We will try to break down this into small pieces and we will try to analyze that. And what about this algorithm? So every time we come into this for loop, this for loop with the value of variable k, this loop is going to iterate for n by 2 number of times. It is a constant in the sense based upon the value of n, those many number of comparisons are done, those many number of iterations are done by this loop every time. Try to get that point. But this is this for loop's job is not going to be constant every time. So it is dependent upon the value of I square. So try to get that point. Dependency is there. So it is dependent on the value of I square. I am trying to make you get this point. This point is very important. Okay. So now every time we come into this loop, this is going to iterate for n by 2 number of times. For example, if the value of n is 100, means n by 2, 50 iterations are done by this. For example, if you come into this loop for 4 times, means 4 into 50. Those many number of times we are going to iterate. Okay, now we will try to break down into small pieces and we will try to understand this. Here the value of, initially the value of I is equal to 1. Okay, when the value of I is equal to 1, I square is how many times does this j iterate? So this means that the number of times these are going to be iterated. So at the value of I is equal to 1, this j will iterate 1 time. And what about k? K will iterate for 1 into n by 2 time, because we are going to come into this j for 1 time, only 1 time. This k for loop is going to iterate for 1 into n by 2 number of times. Okay, the next one is, if the value of I, in the next iteration the value of I is equal to 2. At this case, how many times does this j loop will iterate? J loop will iterate for I square number of times. I square number of times means 4. 2 square. The value of I is equal to 2, I square is equal to 4. So j less than or equal to 4, starting from 1, j less than or equal to 4 means this loop is going to iterate for 4 times. Every time we come into this loop, this k is going to be iterated for n by 2 number of times. How many times we are going to come into this loop? 4 times we are going to come into this loop. Check that point. 4 times we are going to come into this point. So the k come into this loop, so k is going to be 4 into n by 2. 4 into n by 2 number of times this k will get iterated. Similarly, if the value of I is equal to 3, then j is equal to 9, and what about k? K is equal to 9 into n by 2. And what about value of I is equal to n? If the value of I is equal to n, j is equal to n square, and k is going to iterate for n square into n by 2. And now how can we evaluate this the higher order term of this entire possibilities? We have to add all those terms, add all these k values, and we are going to get the final value. From that we are going to get the higher order term. From that we are going to get the higher order term. So how to do that? It is add all those things. It is 1 into n by 2 plus 4 into n by 2 plus 9 into n by 2, so on, plus this one is n square n by 2. So can you guess anything from this? So are there any mathematical evaluations that can be that we are going to get from this? It is n by 2, we are going to take it as common. It is 1 plus 4 plus 9 plus, if there is 4 means it is going to be 4 square 16 plus so on plus n square. So what does this mean? This means that it is sum of the squares of first n natural numbers. Sum of the squares of the first n natural numbers. How can we calculate sum of the squares of the first n natural numbers? So this is going to be okay, this is going to be n into n plus 1 into 2n plus 1, 2n plus 1 by 6, and this entire thing is n by 2. So now what is the higher order term? N into n into n into n. So it is going to be n power 4. The higher order term is n power 4, and the efficiency of this algorithm is n power 4. Okay, so this is how we are going to break down the algorithm, and we are going to get the final solution, the algorithm efficiency. Okay, so coming to our next algorithm, this algorithm is very important. Okay, here what about this algorithm? It looks very simple, but we have to get this. Okay, how to solve this? Here I is equal to 1, I less than or equal to I less than or equal to n, I is equal to I into 2. Every time the value of I is multiplied by 2, the value of the existing I value is multiplied by 2. So how to break down this? If the value of I is equal to 1, value of I is equal to 1, I less than or equal to n. For example, so let's assume, don't assume the value of n. So this loop, in the next iteration, what is the value of I square, value of I? The value of I is going to be, from 1 it is going to be 2. And next the value of I is equal to, 2 into 2, 4. Next the value of I is equal to 4 into 2, I. Next the value of, 4 into 2, 8. Next its value is 16. How many times does this? So at what point we are going to come out of this loop? At what point we are going to come out of this loop is whenever we reach the value of n, we are going to come out of this loop. Try to get that point. Whenever we are going to reach the value of n. So here the value of n. Whenever we reach the value of n, then we are going to come out of this loop. And those many times this statement will get printed. So what is that value? At what point we are going to break this loop? And how this design is? So how this pattern is? How this pattern is it is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, and until this 2 power m. Until 2 power m, when this 2 power m is equal to n, then we are going to, then this value of I is equal to See here, all these values are nothing but the values of I, right? So we are just taking the other form of I. 4 is equal to 2 power 2, 8 is equal to 2 power 3, 16 is equal to 2 power 4. So this is how the things are getting incremented. This is how the things are getting incremented. And at what point this loop is going to get breaked? This loop is will get breaked if the value of I is equal to n. After that, the value of I will get incremented more than 1, then we are going to come out of this loop. At what point we are going to make this I value is equal to n? It is at 2 power m value. Now what is this m value? What is this m value is, whenever 2 power m is equal to n, then we are going to break, we are going to come out of this loop. Now how to get this m value? M is equal to log n base 2. Hope you know this. M is equal to log n base 2. Now what is the algorithm? What is the efficiency of this algorithm? The efficiency of this algorithm, if the value of, so how to get this point in very clearly means, if the value of n is equal to 64, then log 64, value of n is equal to 64 means log 64 is equal to 6. So what does that mean? This loop is going to iterate for 6 times. So this loop is going to iterate for how many times does this loop will get iterated? It will get iterated for m number of times. So what is this m number of times is? It is log n base 2. Log 64 base 2. Log 64 base 2 means it is 6. 2 power 6. So it is going to be 6. So 6 times we have to iterate in order to get the output, in order to come out of this loop. If 64 is the value of n, in order to come out of this loop is going to iterate it for 6 times. 6 times this condition will get executed, and so the entire efficiency of this algorithm is 6. It depends upon the value of m. Try to get that point. So it is log n base 2. Okay. So now for example, if we have the value of I is equal to I into 3. I into 3 means then it is going to be log n base 3. I into 4 means log n base 4. Okay, so this is how the things will be. Okay, so these are some of the examples on algorithm analysis. Hope you got the clarity on this concept. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. And if you have any doubts regarding this concept, please post your doubt in the comment section below. And if you feel that this video is helpful to you, please give us a like symbol and please share this video with your friends so that they will also get benefited. Thanks for watching.